My dear students, very good morning. Myself, Dr. R. Arulprakasam, Department of Mathematics, SR Institute, Science and Technology. Today I am going to discuss Unit 4, Analytic Function. In our Unit 4, we have the following topics I have mentioned here. First one is, what is analytic function? Next, any function I can express analytic function, so you should need necessary and sufficient condition a function to be analytic. Next to analytic function properties, we have to discuss this property. What are the properties is there for that analytic function? The second topic is harmonic function. So third one is the relation between analytic function, harmonic function. So by this relation, we have to do construction of analytic function. This method defined Milne-Thomson. And geometrical way, we are discussing that part is called conformal mapping. So we have only these three mapping we have to discuss in this unit. Finally, bilinear transformation. This is our syllabus defined. Okay, so before that, we need some basic definition. So we'll discuss what is the basic definition. I'll explain one by one. First, what do you mean by complex function? So you know the real function. So we need one domain and codomain, domain and codomain. A function defined like this. So generally in our real function it is denoted by y is equal to f of x, you know everyone. Likewise, we are extending the complex function. So what do you mean by complex function? Consider two complex domain complex number, codomain also complex number. Just to define the function. So it is z plane, it is w plane. So here z map to f of z. So a complex function always denoted by w is equal to f of z. Just note it like this. On some basic, most of the students know that basic. What is the complex number? The notation of complex number nothing but z is equal to a plus I b or x plus I y. Here you know what is a. A is a real part of z and b is nothing but imaginary part of z. You know very well. Studied in schooling level, I think. Okay, this is enough. After that, I'll move on direct to syllabus. What do you mean by analytic function? Today date 10/4/24. So I explain what is complex function. So generally complex number function denoted by w is equal to f of z. So once the function defined, we also talk about these two basic concept. What is that basic concept? Continuity and differentiability. When should I say a complex function is continuous at a point? So a complex function f of z is continuous at the point z naught if limit exists, limiting value, also function value at a point both are equal. So that the condition satisfied means we can say a complex function is continuous at a point. In the domain, each point continuous means a complex function also continuous in the domain. It is well-known definition. So now we'll move on derivative of f of z. What do you mean by derivative? The derivative of f of z, first we can talk about point A and then we can extend the each entire domain. So derivative of f of z at a point z naught is f dash of z, f dash of z naught. So what do you mean by f dash of z? It's a derivative value. What do you mean by derivative? The limit value exists means the limit. What is the limit? F of z minus f of z naught divided by z minus z naught. That limit value exists means we can say limit derivative. The derivative means we can say function, complex function is differentiable at a point z naught. So in okay, a complex function differentiate derivative at each point in the domain D means we can say differentiable in that domain. So I explain what is continuity of f of z, differentiability at z naught. We are both are we are using these two definition. Now we'll move on our syllabus. What do you mean by analytic function? Analytic function, when should I say a complex function is analytic? First, generally we have to discuss about the point and then we are extending in the domain. So a complex function f of z is said to be analytic at a point z naught. We want to say a complex function f of z is said to be analytic at a point z naught means what is the meaning? So what is the meaning? At a point z naught, a complex function f of z is is said to be analytic at a point z naught means if f of z differentiable at z naught and every some neighborhood of z naught. So it is function is differentiable not only at a point z naught, it is also some neighborhood of neighboring point of z naught. So then only we can say a function is analytic. Generally, we are problem we are looking not in the definition. We are not looking the definition manner. We are moving on the some property and condition based. So what is the function? A function is analytic in a domain means if it is analytic at each point of the each point of D. So first I explain complex function is analytic at a point A, and then each point of the domain is we can say a complex function is analytic in a domain. What do you mean? What do you mean by analytic function? It is differentiable at each point of the domain. What do you mean by differentiability? Derivative exists. This limit value exists means that is derivative. What do you mean by continuous? Continuity of the continuity of the complex function is the same thing. Limiting value of f of z equal to function value at a point. Equal means we can like it in the real function. So these are all basic definitions. Now I will move on our main things. We can say any complex function. We can say analytic function. So, so we need some necessary and sufficient condition. What is the necessary condition? So first thing, first order partial derivative existed and the continuous function of the variable x and y in the domain. Next one is CR equation exists satisfied. What do you mean by CR equation? Ux is equal to Vy, Uy equal to minus Vx. It is Cartesian form of CR equation. What is the polar form of CR equation? So we know polar form in terms of r comma theta, Cartesian form x comma y form, you know, right? So in CR equation in polar form nothing but u r equal to 1 by r v theta, u theta is equal to minus r into vr. What do you mean by ur? First derivative with respect to ur means here first derivative with respect to r. What do you mean by ux? First derivative with respect to x. Vy first derivative with respect to y like this. One more thing, the note is very important. Analytic function also we called as a regular function, holomorphic function. Both are these are all different name for analytic function. So I explained what is analytic function and what is the necessary and sufficient condition for analytic function. So we'll go for problem. Before that, we want to say CR equation is nothing but it is a necessary condition for differentiability. So analytic means it is differentiable at every point in the domain. Okay, right. Now we move on the problem based on the condition. So check the following function is analytic or not. So some complex function defined. So I listed 5 problems. We'll do one by one. So f of z is equal to z bar, f of z like that here mentioned. So how I can say defined function is analytic or not by the definition way. So we can use necessary condition. What is the necessary condition? So the function CR equation satisfied means definitely function any analytic function must satisfy CR equation. Suppose CR equation not satisfied means it's not a analytic. That's it. Use this concept. We can solve this out list of the problem. Listen here. Just I consider the first problem. F of z is equal to z bar. What do you mean by z bar? You know z is nothing but x plus iy. Z bar is conjugate of Zn. So nothing but whenever we have in the imaginary part, replace plus to minus n. That is conjugate. You know very well everyone. So then, so here function f of z is z bar is here mentioned. Here I am equating real part and imaginary part of this given function. So it's our real part in here. Real part is nothing but u is equal to x. What is the imaginary part? V is equal to minus y. So what is the meaning? What is the necessary condition I mentioned? So first derivative exists and continuous. So what is that? The first derivative with respect to x? 1. It is constant function always continuous. Uy is a continuous. It's a continuous. So next condition, what is the next condition? This is satisfied CR equation or not? So we have to, what is the CR equation? Ux is equal to V. What is the Ux value? 1. Uy value minus 1. It is not equal. So CR equation not satisfied. So that function is not analytic anywhere. Okay. Okay, we'll go for one more problem, right? Okay, just I can consider problem 2. What is the problem 2? F of z is equal to mod z square. So I can consider f of z is equal to mod z square. So like that we have to think, what do you mean by mod z square? You know what? Let z is equal to x plus iy. You know very well. What is our z bar? X minus iy. What is our z into z bar? So x plus iy into x minus iy is nothing but a plus b formula, a square minus b square. So here minus iy whole square is nothing but what? X square plus y square. So what do you mean by z into z bar? You know everyone, mod z square. So here by the basic things we can write what is our f of z. Here f of z nothing but mod z square. What do you mean by mod z square? It's nothing but x square plus y square. It is f of z. So now you know what is our f of z. You know already u plus iv is equal to x square plus y square. So take real part, equating real part and imaginary part. So our real part u is equal to x square plus y square. What is our imaginary part? So 0 because there is no imaginary part. So trivially we can say definitely it is not satisfy CR equation, therefore it is not analytic. We can say like that. So ux is equal to 2x, right? Ux is equal to vy. So here vy also 0. So 2x not equal to 0. So CR equation not satisfied. So it is not analytic. Got it? So now I'll move on third problem. What is the third problem? F of z is equal to z square. It is analytic or not? So we can verify like this. So f of z nothing but you know z is nothing but x plus iy whole square. So what is the meaning? A plus b whole square formula. A square plus 2ab plus b square. What is the meaning? Just form the complex number structure. A square, what is the I square value? Minus 1. So minus y square plus I into 2xy. It is complex number structure. So from that function, just equating real, this is the given function. This complex function is analytic or not? How I can say? So by use CR equation. So just how I can check CR equation? First to use find out real part. What is the real part of function? X square minus y square. What is the imaginary part of the function? V is equal to 2xy. So find first condition. What is the first condition? Find the first order derivative with respect to x and y because u is function of x comma ux value 2x, uy value minus 2y. Here Vx is equal to 2y. Vy is equal to 2x. It is first order derivative existed. It's a polynomial function. So both are continuous. What is the second condition? CR equation. What is CR equation? CR equation nothing but ux is equal to vy. What is our ux value? 2x. What is our vy value? 2 vy value 2x. So first condition satisfied. What is the second condition? Uy is equal to minus vx. What is our uy value? Minus 2y. Here minus 2y. So it is second condition satisfied. So CR equation satisfied. Therefore given function is analytic. So you can keep in mind any polynomial function is analytic. Any trigonometric function sin x, sin z, cos z, e power z, these are all analytic. Likewise, we can follow problem. Any problem is given, we can do in this manner. Thank you, students. Next class, we will discuss properties.